Hello everyone. Today we're going to pick up from last time, Rutherford's experiment. So he concluded that in the center of the atom we have the protons and the neutrons, and electrons revolve around the center of the atom or the nucleus. Now, protons are positive, electrons are negative, and neutrons contribute to the mass of the atom. The more the number of neutrons, the more the mass. So from the periodic table, we see the elements, symbol in the middle, atomic number on top, average atomic mass on the bottom. Atomic number tells us the number of protons in a neutral atom, tells us the number of protons and the number of electrons. From the average, we can get the mass number, which is equal to number of protons and the number of neutrons. To find the number of neutrons, we just subtract atomic number from atomic mass. You can, of course, pause and just write this down. Now, another way of representing this is called isotope notations. You have the symbol of the element with the mass and atomic number on the bottom. Now, for potassium, the number of protons and electrons will equal to 90. And the mass number, we round it up to 39. And to find neutrons, we just subtract 19 from 39, which is 20. Now, what if we have charges? A net charge, like potassium with 1939 with a net charge of +1. When we have a plus, then we subtract the charge from protons. When we have a negative, we add the charges to the protons. Let me show you what that means. Protons are 19, always the same, they don't change. The only thing that changes is the number of electrons. So protons is 19. The number of electrons will be the 19 minus the positive charge, which is 1. And then the number of neutron will be atomic number minus the mass. Now for oxygen, it's -2, so we add the charges to the proton. So the number of proton is 18, because it's the same as the atomic number. I'm sorry, it's the 8, same as the atomic number. And then electrons, we just add 2 because it's going to be more negative. And the neutrons, we subtract 8 from 16. All right. Now, and for isotopes, potassium has 3 different isotopes, and to represent isotopes you put a dash. So potassium 39, potassium 40, and potassium 41. Now I just wanted you to notice here, electrons are always the same, protons are always the same. The only thing that's different in an isotope is the number of neutrons. Okay, same protons, different number of neutrons. That's isotopes. All right, now in order for us to find the average, which is the number that you see on the periodic table, it's not like taking the average of all your test scores. There are steps. So let's look at this problem. Boron has 2 isotopes, boron 10, boron 11. Boron 10 exists with an abundance of 19%, 19.8%, and a mass of 10.013 atomic mass unit. Boron 11, abundance 80.2, mass 11.009. What's the atomic mass of boron? There are 3 steps. Step 1, you divide by 100 to get rid of the percent sign. So you want the decimal. Second, you multiply by the mass. Whatever you get, you multiply by the mass. Second, you add them all up. So let's see what that would look like. Boron 10, boron 11, you write down the percent. First, you find the abundance, which is you divide by 100, and then you multiply by the mass. So whatever they put in parentheses, that's what you multiply together. And then the last step, we add them all up and we get the average mass. Okay, I think that should help with the handout and the Teach Me assignments. I hope that helps. We'll see you next time.